Assalamualaikum warahmatullahi wabarakatuh. Respected Mr. Nofri Suhermi, as the lecturer of Statistical Machine Learning Kai, we would like to present our final project titled Comparative Analysis of Random Forest, SVM, and Logistic Regression for Diabetes Classification. Before we begin, let me introduce our team. First, I am Risma Divashabila with student number 002, followed by Mohjanwar Akbar, student number 1773, and Husnan Ali Husnan with student number 133. Next. The topic we will cover in this presentation include the introduction, literature review, methodology, result and discussion, and conclusion and suggestion. Next. For the introduction, it is important to know that diabetes is a chronic disease marked by high blood sugar levels. Early detection of diabetes is vital for preventing complications and enabling effective treatment. Machine learning improves accuracy and efficiency in classification tasks. Previous studies on Pima Indians Diabetes Dataset is random forest achieved 19.6% validation accuracy. Superfactor machine achieved 80.48% accuracy, and logistic regression achieved 83.13% accuracy. This study compares the performance of random forest, SVM, and logistic regression in classifying diabetes using the Pima Indian Diabetes Dataset, focusing on accuracy, sensitivity, specificity, and AUSE. The findings are expected to identify the factors influencing diabetes and contribute to reducing diabetes cases. Next. And then for the methodology, and then for literature review, we have diabetes, the definition of diabetes. Next. Diabetes is a chronic metabolic disease characterized by elevated levels of blood glucose, which lead over time to serious damage. Diabetes is broadly classified into two primary types, is type 1 diabetes and type 2 diabetes. Next. And for machine learning is a subset of AI that focus on developing algorithms. Machine learning models can be categorized into four main types: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Next. And then the definition of classification is one of the primary tasks in machine learning, which involves predicting a discrete label or category for given input data. Classification is vital across fields, using tailored algorithms to address challenges like imbalanced data, overfitting, and feature selection. Next. And then for random forest introduced by Leo Bremen in 201 is an ensemble learning method that enhances predictive accuracy and control overfitting by combining multiple decision trees for classification and regression tasks. Next. And then the definition of SVM or supervisor machine is a method aimed at finding the optimal separating hyperplane between two classes by maximizing the margin between the nearest class point. Next. And then the logistic regression is a widely used statistical method for binary classification tasks, modeling the probability of a binary outcome based on one or more predictor variables. Next. And next, for the methodology, our research covers several key points, including the data source, data structure, research variable, research flowchart, and research process. Next. For the data source, this study used a dataset from the National Institute of Diabetes and Digestive and Kidney Disease available on Kaggle with 768 observations of Pima Indian females aged 21 or older. The dataset aims to predict diabetes based on given measurement. Here are some research variables that we use. That are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, age, and outcome with the description here. Next.
For the data structure itself, we have pregnancies, glucose, blood pressure until age for the independent variables, which all of them is numerical variables with the response itself is the outcome, with 1 being diabetes and 0 being not diabetes. It's a categorical variable. Next. For the research flowchart itself, we have this image, we would like to explain it more in the research process. Next. For the research process itself, the steps of analyzing content in this study are as follows. Identifying and formatting the problem in line with the chosen topic. Second, searching for the dataset to be used to the Kaggle, which is our Pima Indians. The third, performing data processing involving several steps like checking data types, checking handling missing value, duplicate data, handling outliers, and transforming the data. Fourth, performing feature selection on the dataset that has undergone pre-processing. Fifth, splitting the datasets into testing and training, and then keyword cross-validation method with K equal to 10. Six, specifying the diabetes into positive and negative cases using random forest, SVM, and logistic regression algorithms. Seven, evaluating the model based on accuracy, sensitivity, specificity, AOC, ROC curve. Next. Further research and discussion. Next. For the data preprocessing itself is carried out and as an initial step to prepare the data before being used for further analysis and to have better model results. These following steps are the part of data preprocessing, such as data summary, with in the result we have the outcome variable is in imbalance data and variable for pregnancies until age itself is doesn't have a similar deviation and similar range. Therefore, we need to process that with certified and normalizing. Next. The next step is to check for duplicated data and missing value. We have in this table that our data itself doesn't have any missing value and duplicate data. Therefore, the dataset is ready for further analysis. Next. After that, the diabetes dataset is checked in visualization by box plot itself. Outlier are checked using visualization method. Therefore, data is cleaned by removing outliers that are above quarter 3 and below quarter 1 for each variable. Before moving on to the next step, the clean data needs to be checked again for outlier in each variable. In this table, checking outlier clean data. Therefore, our data doesn't have any outlier gain. Next. Relevant data that has been cleaned for classification needs to be standardized or normalized for further analysis in order to improve model performance and avoid bias, especially in SVM. Without normalization feature with larger range will have greater influence on performance. Therefore, the dataset is ready for further analysis. Next. Filter selection is a crucial step in data processing, which chooses the most pertinent subset of feature from the dataset that is accessible. Redundancy and relevance in filter can lower the model performance, which filter selection is used to address this problem. One of the methods for filter selection is by using random forest model filter importance. For this analysis, our filters are used because there are many filters or variables, and using them improves the model accuracy. Next.
After data preprocessing steps, use classification with the three models. The first model is random forest, second model is superfactor machines, and the third model is logistic regressions. With the validation method is k-fold cross-validations. The dataset is split into 10 folds with k is tens. Each fold is used as a validation data while the rest serve as a training data, provides as a more accurate measure of model performance. And the parameter tuning we use in the random forest is number of tree entry 500s, number of feature per splits range between 2 and 6. Validations method is 10 folds cross validations. The next slide is the sample decision tree from the random forest models, showcasing the hierarchical splitting based on the features such as age, glucose, BMI, and the blood pressures and AOC curve from the random forest model. This is the visualization of the sample decision tree from random forest and ROC curve with AOC for random forest. The ROC curve illustrates the model trade-off between sensitivity and specificity with an ROC of 0.789, indicating moderate classification capability. And the second one is superfactor machines. Parameter tuning we use that is kernel radial basis functions, RBF, with regularization to one using a grid search, gamma, kernel coefficients tuned using a grid search with the validation method with use tenfold cross validations. And the next slide is ROC-LC curve from the support vector machine model. This is the definition of ROC curve with the OC for SVM, and the ROC curve below demonstrates the trade-off between sensitivity and specificity for the SVM model with the OC of 0.805. And the last one is logistic regressions. Logistic regressions, the pattern we use is regulations type of L1s, lasso, and the second one is regulations parameters, tuned between 0.01 and 0.1 using grid research. And validation method we use tenfold cross validations. And the next slide is ROC-LC curve from the logistic regression model. This is the visualization of ROC curve with LC for logistic regressions. With the ROC curve below illustrates the strong performance of logistic regression with an LC of 0.847, indicating high classification capability. After classification analysis using 3 models, we evaluate the best model for the search choosing the best models. This is the table below summarizes the performance metric of the 3 models, with accuracy for random forest is 0.819 and accuracy for supervector medicine is 0.771 and accuracy for logistic regression is 0.831. And we got that random forest is high specificity with 93.44 but lower sensitivity 50.00, making it less effective at identifying diabetes cases. And since support vector machines, we evaluate performance across all metrics with OC 0.805 with lower accuracy and sensitivity compared to logistic regressions. And the last one is logistic regressions have the best performance overall, the highest accuracy with 83.13% and OC 0.847, balance sensitivity 54.55% and specificity 93.44%, making it the most reliable for diabetes classifications. And we have the conclusions that the study compared the performance of random forest SVM and logistic regression in diabetes classification using the Pima Indians Dataset. Scanning our logistic regression achieved the best performance and the highest accuracy, and a balance between sensitivity and specificity. But random forest excel in specificity but had low sensitivity, limiting its effectiveness from detecting diabetes cases. And the last one is SVM saw the moderate performance with an accuracy of 0.805 but lower accuracy and sensitivity compared to logistic regression. And we have suggestion for the model development. The first one is explore advanced algorithm like gradient boosting or neural networks. And second one is fine-tuning logistic regression and random forest parameters. And second one is suggestion for data development. This first one is collect larger data set with additional attributes. Example, family history or lifestyles. And second one is balance the dataset to reduce class bias and improve sensitivity. And the last one, we add the NRCNE dashboards to make the visualization more attractive. The first panel, there's a home panel containing the theater of analysis. And then we can click get started and interactively open a YouTube link about the Pima Indian Diabetes Dataset. Next one, on the second panel, there's this database panel displaying the structure of the dataset being used. When we click data summary, the table showing descriptive statistics appears. Additionally, there is a option to download the file with the desired formats, CSV, PDF, and Excel. And the third one is the panel of visualization. And the top panel, we got total diabetes cases, average age of diabetes patients, average BMI of diabetes patients. And more visualization with the first one is histogram charts. Second one is scatter plot charts for BMI versus age by diabetes status. And third one is stacked bar charts for distribution of diabetes by BMI category. And the fourth chart is age category division by diabetes status with the bar charts. And the last one is pie charts for the diabetes status distribution. And then the final analysis, we got the model evaluation results with the model rainforest SVM logistic with the erosion curve with OC areas and the rainforest decision tree visualization. And then the last one, we got panel predictions to make a prediction with the model we choose, random forest, SVM, and logistic regressions.
Okay, thank you for your time and attention. I hope this project contributes to the field of diabetes and inspire future research. Wassalamualaikum warahmatullahi wabarakatuh.